Hello everyone, good afternoon. My name is Veerbhadra Patil. I'm from Skillemme. So welcome all, first of all, for this webinar on AI. I would like to get started with a small introduction about our organization. Skillemme is an innovative edtech company, redefining the way learning happens in today's fast-paced world. With a curated learning library and tailor-made programs in key areas like technology, leadership, executive education, soft skills, wellness, and professional degrees, we empower teams to stay ahead in their fields. Backed by the founders with collective 30 years of experience in the learning industry, Skillemme is committed to delivering dynamic, relevant, and impactful education solutions for the modern workforce. So it is my pleasure to introduce our esteemed facilitator, a highly accomplished principal AI engineer with close to 15 years of experience delivering cutting-edge cloud-based project pipelines. With expertise in generative AI, deep learning, and large language models, our facilitator has a proven track record of developing advanced AIOps and MLOps pipelines using AWS Azure and harnessing platforms like Snowflake and Databricks. So he brings unparalleled knowledge in building innovative solutions such as RAG architectures, fine-tuning and pre-training models, and implementing advanced prompt engineering techniques for AI customization. His vast experience spans developing agentic architectures, healthcare-focused AI solutions, diffusion models for medical imaging, and much more. A true thought leader in the AI and data engineering domain, he excels in combining technical expertise with agile methodologies to deliver impactful end-to-end solutions. So let's gear up for an insightful session as he guides us through the fascinating world of cutting-edge AI technologies. So please join me in welcoming Mr. Rajiv. One moment, Rajiv. I'll just make you the host.
Hey, hi. Thank you, Satish. Thank you so much.
Thank you.
Hey, hi. Good afternoon, everyone. Able to hear me? So this is somehow my random studio setup. Sorry for that. And able to hear me? Am I audible? Yep, perfect. So let me share my screen. And thank you, Satish, for your welcome. Thank you so much. And thank you guys for joining today's class, where let's start with how for example, AI going to work. So before I'm showing you certain use cases, and how many of you are using AI in your day-to-day life? Before I'm about to start, I just want to explain this concept. And this is something more to a human, but how many of you are using AI in our day-to-day life? Everyone? Is it like everyone uses AI in our day-to-day life? Yep, perfect. Now, today, let's see different use cases, how we are using AI. But before I'm going back and showing use cases, I want to explain you this 4 elements. So if you are able to understand these 4 elements, you can easily understand how AI is developed. Or even if you want to go and develop it, you can start developing it with ease. So with the help of this 4 layers. Now humans are actually, means I'm just dividing humans into 4 different, not humans, the way humans are able to use their actions or how they are able to perform an action. I'm just dividing it across the 4 categories. The very first category, I call it as data collection. So now what exactly this data collection going to do? Now, this data collection happens with the help of sense organs. So now what are the sense organs in simple? If I'm able to, if I'm able to take this data collection, we are able to call it as sense organs. And the sense organs can be like our eyes, or we are able to collect the data with the help of our ears. We are able to collect the data with our nose, we can smell it. And with our hand or with our skin, we are able to collect the data like temperature, we can feel it. There are various elements we are able to collect it. Now, if I want to perform the same data collection, even using our AI world, I will be connecting the data with the help of sensors. or I'm able to collect the data with the help of website, or I can say web applications, or even I can start collecting the data with the help of mobile applications. I can start collecting all the data. For example, people are buying a product, I can start collecting their data related to purchase pattern. Or someone is browsing the website, I can collect their data, how much time he's spending on which page he's available. All this data I am able to collect it. And if you are able to take sensor, the smart watches we are using in our day-to-day life, they are collecting data points related to our heart rate, they are collecting data points related to temperature, so various other metrics. Now the sense organs here in our digital world, so we are having our sensors. If you're able to take a Tesla car, there are sensors. So camera also acts like a sensor. With the help of camera, we are collecting the data of images, same like an eye for a human. We are using cameras which are sensors which are used to collect the data of image or video. We are using mics in order to collect the data of audio, and we are having various pressure sensors, temperature sensors, and all this. We are collecting various data points, even from a manufacturing unit, from a human body, so from a car or from a mobile phone, etc. We are able to start collecting the data. Now humans are collecting the data with the help of sense organs, and after collecting the data with the help of sense organs, then what they are doing is they are trying to perform data storage. So what exactly meant by this data storage is, now you are able to look onto my screen, you are able to see, hey, there is a slide of AI implementation. Now you are collecting the data with the help of your sense organs. Now you need to recall it inside your memory, or you want to recall it to your brain. If you are unable to recall it to your memory or to your brain, so we may not be able to remember it. If I ask you a question, can you tell me about AI versus generative AI, or can you tell me about what is agents versus something like LLMs? Now your ears are able to collect it. Now you can remember it, or you can store it into your brain or into your memory, but you may not be able to perform intelligence. So what exactly intelligence? I asked you, can you tell me about agents? There are two ways. One, you listen to it with your ears, you're able to listen it, or you are able to view it with your eyes, and you are storing that into your memory. And if you have an intelligence about AI agents, then what you will be doing is you are trying to perform, or you are able to start giving an answer in the format of your text, or you are able to start giving an answer in the format of your what is that, audio, or you are able to start giving an answer in the format of your what is that, gestures, and any of this. Now the same thing when you are trying to, so I feel a bit means there is a different setup. I'm just let me 1 minute. The 1 minute.
Yeah. Guys, give us a minute. Sorry for the inconvenience. Just a moment. We'll be joining back.
Yep, sorry. So there is some issue with my uh, setup. Sorry for that. Yeah. Yes. So now, as I said, data storage helps us to store the memory inside our brain, and you got an intelligence. Now, this is like by learning. For example, now you are going through this webinar. From this webinar, you are learning it. Now, humans are able to gain intelligence through experiences, or we are able to learn it with the help of the way we are interacting with the world. We are able to gain the intelligence. And based on the intelligence, I asked you a question. For example, tell me about AI. Then what you will be doing? So based on your data collection, the ears are collecting the data about AI. It is storing inside the memory. And you already learned about AI. So based on your intelligence, you are saying, hey, Kant, you are responding now. Based on your intelligence, you are giving an action. Hey, Kant, AI is all about maybe like developing an artificial intelligence to a machine. Now, these are the four building blocks. So the first one going to be data collection. We are trying to collect the data with the help of sense organs. And the second one going to be your data storage. So here the data collection is happening with the help of sensors. Example, if people are using ChatGPT, so ChatGPT can be an example. You are collecting the data through ChatGPT, and we are storing the questions you are asking in the ChatGPT. So it's going to have a memory. So ChatGPT is able to store the particular information, and then you are having an intelligence. So what is having ChatGPT is having an intelligence. You are asking a question about what is AI. So based on the intelligence it developed it is able to give a response on your ChatGPT or on your Gemini, stating, hey, this is what artificial intelligence is. The same way, you are writing a question to your ChatGPT, you are storing that into a memory, and based on the intelligence, it is able to write down a code for you, or it is able to come up with a PowerPoint presentation for you. These are the four building blocks. Even if you take your phone, now within your phone, now your camera is acting like a sensor data collection unit, and you are able to store the data in your phone memory or your phone storage. And based on the intelligence, whenever you take an image, if the quality of an image is not good, based on its intelligence to transform a regular image into a high quality image, we are able to get an action of a high quality image. Or it is able to remove the background of an image. Based on its intelligence, it is able to remove the background, or it is able to make or set the camera settings proper. So the same architecture. And the same thing you are able to see within your phone keypad data collection. You are typing a word like hi, it is having a storage in your phone. Based on its intelligence, it is able to provide recommendations in your phone. If you are typing hi, it is able to give you a recommendation saying, hey, how are you, what are you doing. It is able to do this kind of suggestions, it is able to perform. So now these are the four steps we are able to achieve it in any AI implementations. Do you notice it, these four steps? If you are able to link it up your day-to-day AI things which you are interacting with, can you see them or not? Yes, you're able to see them. Now, one of the use case. Now, for example, are you aware of agriculture? How many of you here are aware of agriculture? So please ask me, Harish. You can ask me the question. That's right, Harish. Now you are able to tune the way the actions are. You are able to code the sequence of the actions, or you are able to code what you can do. Example, now you are collecting the data. Let's say your Tesla car. What is the data collection? Your camera of a Tesla car is trying to collect the data. We are storing that information in the memory, maybe of the car, or you are trying to push the memory to the cloud platform. We are trying to store every image, we are able to grab it, so with the help of the phone, or so with the help of your car. And there is an intelligence. So now what this intelligence is doing is it is able to segregate whether it is a human or a car or a lorry or something else. And based on the intelligence, so it is calculating a distance using another sensor, and based on all these metrics, what action to be done. For example, if you already coded, for example, if there is a pedestrian very close by, you are having a very high speed, then you want to automatically trigger your ABS, or you need to trigger automatic braking system. So in this way, you already fed certain actions what to be done. So based on that actions, it going to perform the action. So based on the image, if the intelligence is saying this, then based on this intelligence, what to be done. For example, I'm recognizing a pedestrian, we are at the speed, then what to be done? Hey, hit the brake. For example, based on the intelligence, I'm able to see there is a particular human face, this guy look like a thief, then do one thing, don't open the door, don't unlock the particular door. Hey, this guy looks like a owner, unlock it. Now based on the intelligence, you are giving a rule what to be done. Got it, Harish? So you are able to use both structured and unstructured data. If I'm able to dig deeper, now data storage can happen in two formats. Now you are able to collect two different types of data in the data collection. One, you can have a structured data. You can have unstructured data. Now, if you are trying to collect structured data, is more like a tabular data. If you are trying to collect tabular data like your Excel or SQL, you will be storing this kind of data inside a data warehouse. If you are trying to store unstructured data, then you are trying to store this entire data inside a data lake. So we use data lake to store unstructured data like images, video, audio, all this you store it in data lake. And all the structured data, the tabular format data, you are trying to store it inside your data warehouse. Got it? Yes. Let me show you two different use cases which are happening. Have you gone through an use case called as Gemini? Anyone gone through it? Gemini Astra, or we can say Project Astra. Have you saw that Project Astra video? Let me show you one Project Astra. Just I unshared it. I'll be sharing in a minute. Now this is Project Astra. See whether you can hear it or not.
Okay, let's do some tests. Tell me when you see something that makes sound.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AESCBC encryption to encode and decode data based on a key and an initialization vector, IV.
That's right. What neighborhood do you think I'm in?
This appears to be the King's Cross area of London. It is known for its railway station and transportation connections.
Do you remember where you saw my glasses?
Yes, I do. Your glasses were on the desk near a red apple.
What can I add here to make this system faster?
Adding a cache between the server and database could improve speed.
What does this remind you of?
Schrodinger's cat.
All right, give me a band name for this duo.
Golden stripes.
Nice. Thanks, Gemini.
So this is Project Astra. And similar to that, we have one more. This is not like Gemini or this kind of one. It is called as See and Spray, which is used in, what is that, agriculture. So See and Spray, John Deere. Now, let me, See and Spray, where is that?
It started here. In fallow. It started here. In fallow. Did you check the sprayer?
I did. You didn't see it parked out back?
Oh no, I must have missed that. Well, let's talk about the See and Spray Ultimate and how it sees, targets, and kills weeds. To tell us more, I'd like to introduce Ryan Steen, Product Manager for See and Spray. So, Ryan, as I'm looking at these crop plants, I'm not seeing any weeds. What can we do about this?
Let's add some in. Let's add in some water hemp, kochia, Palmer amaranth, and horseweed.
How did you do that? Never mind.
So these weeds not only rob the crop of nutrients, of moisture, and of yield, but they're also incredibly difficult for farmers to get rid of.
So, how can a sprayer tell the difference between a crop plant and a weed?
See and Spray Ultimate uses proprietary camera technology that was developed by Blue River Technology, a subsidiary of John Deere. So it uses computer vision and machine learning to scan the field constantly for weeds from crop, and then sprays only the weed. So let's bring it to life. So as our 120-foot boom goes across the field, there are 36 cameras mounted on it. It's constantly collecting high-res images. Those images are sent to the graphics processing unit, which houses the machine learning model. Then that model determines if there's a weed present or not. If there's a weed present, we turn the spray on, and then we spray that weed. That all happens at 12 miles per hour. So we're looking at 2,000 square feet every second. This is what we call green-on-green detection.
Green-on-green detection.
Yeah, so instead of just looking for green and spraying green, we're looking for a specific trigger to spray. So if it's a crop, we're not going to spray. But if it's one of these weeds that were in the field earlier, we're actually picking out the specific plant that we want to spray, all in real time and in the blink of an eye.
All in the blink of an eye.
So this is called as See and Spray technology. I hope you got it, how this is working, See and Spray. Able to understand how we are able to get that See and Spray? Let me just explain you how it is working. So in a See and Spray technology, let me start with Gemini, and then let me go with your See and Spray technology. The data collection in Gemini is happening with what? We are using data collection with the help of camera and with the help of mic, and even within the camera you are able to collect images, you are showing gestures and all this. So like it is able to collect that, and even I can say it can be image or it is a video. We are able to provide this kind of data collection is happening. We are storing that in a cloud, and most of the data we are collecting from Gemini is mostly an unstructured data. So you want to store it inside a data lake. And I developed an intelligence. So like the intelligence is where it can understand the data and it can generate the data out. So now there are two different types of intelligence in our world. One is called as discriminative intelligence and another one is called as a generative intelligence. So what exactly meant by discriminative intelligence and the generative intelligence is, if I'm able to give one part of the data, it is able, for example, here I provided different paintings and I said what exactly this painting is. I said this painting as 1, I said this painting as 1, this painting as 0. So I gave certain labels or discriminations. Example, I'm showcasing an image to a kid. I'm saying, hey, this is your father or this is your mother. So now whenever he sees an image, he say, hey, he's my father or this is my mother. The kid can start discriminating between a mother and a father. Discriminative models. So now, for example, I'm able to classify, hey, this is a pedestrian or this is a car or this is a blurred image or this is this. So it is able to discriminate it, but it cannot generate it. So what is a generative models are? If I'm able to give one part of the data, they can start generating another part of the data. So now if you take this Gemini example, I gave one part of the data, what is that image? Or I gave one part of the data like audio or a video, then based on its intelligence, generative intelligence, it can start generating a data. Oh, this is called as this code. It can write down a code. What is the action based on its intelligence? So writing down the code is the action. So based on the intelligence, it is able to write down the code, or based on the intelligence, it is able to use its audio and it is able to respond back is the action, or it is able to write down the code. So that going to be your generative model. So the difference between generative models and discriminative models are, generative models are able to generate the data. If you are able to give one part, they can start generating another part of the data. Whereas discriminative models can say father or a mother, or it can say cat or a dog, or it's a good explanation or it's a bad explanation. The difference, you are listening to my class, you are saying, hey, this is a good one, or it's a bad one, or it's an average one. You can say that. Or you can, based on the provided data, you can start, means like improvising this lecture, and you can make it, for example, I'm doing for 1 hour, you can expand this lecture, you can make it for a 10 hours content, generative AI. Now the same 4 blocks. And if you are able to see the see and spray ultimate, if you are able to see the example of see and spray ultimate, what exactly we have done in the see and spray ultimate is, now we are collecting the data. Why exactly see and spray ultimate? The simple task is, whenever you are, means going with your agriculture, while you are, means like going with your plants and all that crop, now for sure with the crop you are able to get some weed plants. So what weed going to do, they are not, for example, you are trying to go with maybe like a banana tree, or maybe something else, some, for example, you want to go with corn example. Now you planted only the corn seeds, but you started getting some weeds. So they are, what exactly these weeds are doing, whatever the soil moisture we are having, whatever the food you are trying to give it, so now all this, whatever it is having, soil moisture, temperature, so the nutrition which you are able to have it in the soil, so all the weed plants going to consume it. So because of all the amount of consumption happened by the weed, there may not be sufficient amount of supply to the actual crop. Because of that, the actual crops may not be able to give us the yield as we expected. For that reason, farmers, what they do, they go across the farm, they try to notice they need to check every plant, hey, is there any weed? If there is a weed, they are trying to spray the herbicides to the weed plant, so that the weed plant going to die. That's what the farmers are doing. That is a very tedious task. Now instead of doing that, what these people done is, they created a boom where we can attach it to a tractor, and while you are going across your field, you are able to, this cameras in for that particular boom, they can collect the data. So the cameras are collecting the data, and we are storing that within that particular memory. So this may not be cloud, that going to be, we can say chip based. I can say chip based, or I call it as edge computing. So if you are trying to store the data within that particular device itself, within that boom, or within your camera, so we can call it as edge computing. Now we are collecting the image, and based on the intelligence, now what type of intelligence we have? Discriminative intelligence. So it is trying to say, hey, this is a crop, then if it is a crop, don't spray the herbicides. So don't spray the herbicides. If it is a weed, then you need to spray the herbicide. So now the intelligence is, it is able to distinguish between a crop versus a weed, so that we are able to say whether it is a herbicide. If it is a crop, don't spray herbicides. If it is a weed, spray the herbicides. Again, the same architecture. Now able to understand the 2 use cases? Got it? Perfect. Perfect. Now the similar example to this. So if you are able to go with, there is some automations happened across medical scribing and all that. Harish, I don't have any use case. Capital market is, I don't have. Let me show you some examples. I have customer service automation. Yeah, let me show you customer service automation. This is customer service automation. Not this. This is some credit card concern. I hope you got it right. This is an example around the banking, where how exactly the fraudulent transactions can be identified, and mostly it's an AI assistant which you are trying to. It's generative AI assistant. You are replacing the support roles, especially with the help of this. You are replacing the support roles. And every time while you're identifying the use cases, it's as simple as this. So whenever you are trying to identify the use cases, try to identify it with a simple diagram. Now, whenever you are trying to automate any process within the banking industry, see, if the day means like there are two types of activities. One is probabilistic activity, and another one going to be a deterministic activity. So what exactly meant by probabilistic activity and a deterministic activity is, for a fixed input you get a fixed output. We call it as what? Deterministic. For a fixed input you are getting a fixed output. Example, now I'm trying to deposit a check. While I'm depositing a check, data collection is happening what? So now here the data collection going to be image format. Now you need to have the sensors which can scan and which can extract the check. So now if there is a check, I need to look at the check data. I want to extract the fields. After extracting, I want to store it into the memory, whatever the data I collected. And I need to have an intelligence so to match the particular account number. So whether for this account number, do we have the funds? In case if we are having the funds, we need to verify the signature. We need to verify the person name or whatever it is, and based on all the details I want to perform an action. So that is a standard approach. So now whether a human is doing, whether AI is doing, that is a same deterministic approach. For a fixed check you need to give a money, that is the same output. There is nothing like you are going back and you are every time there is a different output. No, it is called as what? Deterministic. For a fixed input you are getting the same output, deterministic. And what is a probabilistic is, for a fixed input you are able to get a varying output. What exactly meant by that? Now, for example, the same biryani, or for example, take a biryani, pasta, pizza, whatever it is. Now you like it today. The same pasta, without your means like approval, I placed an order. Do you like it? Now, if I'm asking you, checking your mood and placing an order makes sense. But without checking it on my own, I decided and I just placed an order. You may not like it. One day you may like it, one day you may not like it. So that is called as probabilistic. The outcome is random. So now you cannot expect the same outcome every time. For example, now there is a customer who came with a shouting. I cannot use AI there. Why? So now the way a human responds, he molds himself based on the way other customer is responding, so that you are able to minimize that outcome. So if you are going with the AI kind of systems, where you need to design an AI system is, if your outcome is deterministic. So check example, or if you take a fixed answers, for example, the Gemini is using a some kind of fixed, it's not a fixed answers for this code, what exactly it is doing, like a question and answer, it is able to generate it. Or whether it is a crop or whether it is a weed, for a fixed input you get the same output. We are able to use what? AI. whenever you're looking into the use cases, always think it in this way. If an outcome is deterministic, that going to work for your AI solutions. Now, in order to make your AI successful, the key element is historical data, the quality of the data you are providing. Now, for a chat GPT, if you are provided all the data about Hindi, means like wrong words, your chat GPT can start speaking in that same foul words. Your chat GPT can speak Hindi with all the foul words your chat GPT can speak, and it may feel it as right. The reason why, whatever the data you are providing, it learns the same thing. So if I want to build an AI system right now, what is more important is data. If you are having a quality data, your AI systems can start mimicking those activities. And if you are trying to achieve an outcome which is probabilistic in nature, stock market is a probabilistic in nature, so it is not deterministic. For a fixed input, if you are going back and investing, you don't get the same results every time. You get a varying results. I cannot go back stock market with an AI. If I do it, it's going to be a blunder mistake. So now that's the reason, first one, you need to have a lot of historical data. It is understanding historical data, and it is trying to mimic the answers. And how exactly the AI is learning? Anyone got that out? Hey Khan, how these AIs are learning? Any guess how these AIs are learning? Is it with coding or with data? How they are learning? So they are able to learn with the help of data. They are able to, AI are able to learn it with the help of data plus math. They are able to learn with the help of what? Data plus math. Now, example, let's take your Swiggy. Do you use Swiggy or Zomato? Do you use Swiggy, Zomato, any of these apps? Everyone uses it. Very simple. Now, till now, you placed 100 times in Swiggy. Till now, you placed an order of 100 times in Swiggy or a Zomato. Out of 100 times, you are able to, for example, place 60 times biryani. So what is the chances of buying a biryani in Swiggy is 60 by 100. So there are 0.6% chances, or we can, sorry, 60% chances that you are able to buy a biryani if you are trying to place an order. And I want to, the goal of Swiggy is not to sell only biryani. I want to recommend you with other items. So now which items I want to recommend it. So for that reason, so how many times within the 60 times, how many times you bought biryani with some butter naan? So out of 60 times, I bought 50 times biryani with a butter naan. So 50 by 60 going to be the probability of buying a butter naan with your biryani. So now whenever you are buying a biryani, based on this probability scores, I'm able to recommend you the particular butter naan. And while you are trying to buy a product as well, based on the historical data plus the mathematical equations, I can recommend the right content. So the same equations are available in all the people's mobile. If you install Swiggy or Zomato, they are the same mathematical equations. But the data of your account is varies. The way you purchase differs, the way your friend purchase differs. So based on that, the pricing changes. Even in the Zomato or Swiggy, the minimum cart price also changes. So 100 times you placed an order. So now each cart time, average cart price is somewhere around 500 rupees, for example. Again, based on the probability, what I can do, I don't recommend restaurants with 100 rupee cart price or 200 rupee cart price. I recommend minimum items of 500 rupee. Why? Average cart time, cart price for you is 500. So now how your AI is developed with the help of data plus with the help of mathematical equations. So if I want to learn, if I want to develop intelligence, I can develop it with the help of what? Data plus mathematical equations. I can start developing the intelligence. So these are the various approaches how you can start developing the intelligence. I'm not going deep into it, but these are the one. So you can start developing the intelligence with the help of unsupervised learning, supervised learning, semi-supervised learning. So self-supervised learning is also called as generative AI, reinforcement learning. If I want to build a Tesla car, it is a part of this 5 types. If I want to build a computer, means like if I want to build a chat GPT, it is within this 5 categories. So whatever the AI work you are seeing right now, it can be your mobile, it can be your laptop or whatever it is, it may not means beyond this 5 types. So anything we are building right now, it is within this 5 types. Recommendation engine is also working in the similar lines, Harish. So recommendation works on the data of different. So for example, if you take YouTube recommendations, so we are able to provide recommendations with the help of your channel, which channel he is watching, what is the category of that particular channel, how much time he's spending, all this going to happen. Okay. Mostly we are using math plus data. And in order to make it possible, we are trying to do all this with the help of Python programming. So I write all these algorithms using Python by collecting data plus by using math. Got it? So we are doing everything in Python programming, and intelligence is developed using data plus math. So now there is an architecture for coding. If you are able to take, this is one architecture. Let me just show you. This is neural network architecture. Normally there is a very heavy concept. This is, for example, if I want to take a blurred image, or if I want to take a blurred image, I want to make a HD image. This is the architecture we use it. Mathematical coding wise architecture, this is how we do it. I can use AI in stock market RAM up to an extent. The reason it is probabilistic in nature, we need to take probabilistic algorithms. Probabilistic algorithms are for the same input. Example, what is a probabilistic and what is a deterministic is this. Now go back to your Google, for example, .I. For example, here you are searching for what is AI. You are searching for what is AI. If you are searching for what is AI, you are able to get this results. Now, again, I'm re-executing that. Is there any difference in the results, or you are getting the same results? Again, let me re-execute it. So even though you are re-executing it multiple times, for the same input, you are getting the same output. On the another side, if you are able to take ChatGPT, or if you are able to take Gemini or any of this, for the same input, keep on executing the same input. Do you get the same output? If you are using ChatGPT or Gemini, for the same input, do you get the same output? If you are retyping the same input multiple times, you don't get it. Every time you get a different result. That they are your probabilistic models. Now whatever the Google search engine, all this are more like your discriminative approaches. We are able to even use AI for stock market, but how well you are able to identify that probabilistic pattern. Now AI works when you can grab a pattern. When you are unable to grab a pattern, it doesn't work. As simple as that. Now if you can grab a pattern of how stock is behaving, works well. So you are able to build an AI system around analyzing that. If you have every data point, how a senior guy can analyze a stock market, if you can have a data points around it, I can develop an AI system. If I want to build an, let me show you. If I want to build ChatGPT kind of level intelligence, then I will be using this kind of architectures. We call transformer architecture. This is one. I will be coding this architecture in Python. It contains mathematical equation. These are mathematical equations, attention equation. So we compute this attention weight so that your ChatGPT can understand what you are typing well. This is how the entire architecture works. Means I never use those apps, Harish. The stock market apps especially, means as I means I don't actually believe them, but I don't know if anyone used it, how close they are to the reality. I don't know. So is it clear? Any doubts you have? So in simple, Harish, right? Now the same architecture, if you go across all these AIs, whichever you are learning, it is the same architecture. So what is changing in AI is take it like a human. Now, what differs from one human to the another human is the knowledge, the intelligence. So a guy who is very good at knowledge in interior design, so he's what exact everything is same. He has the same parts, everything they are same. But the amount of data is he consumed a lot of data about interior designing, and the outcome going to be related to that. The same way, a guy who is in BFSI, the data he consumes is related to banking, finance, insurance, and all this. A guy who is into manufacturing, he consumes data about manufacturing. Now, if the entire mathematical equation, architecture, coding, everything is same, but what is changing from one industry to another industry is the data. And thank you so much, guys. I hope you are able to understand it. Thank you for your wonderful time.
Thank you, Rajiv,
Thank you.
for the insightful session. So as we come to the end of this enlightening webinar on artificial intelligence, right? So my heartfelt gratitude to Mr. Rajiv for sharing his valuable insights and expertise with us. So I'd like to thank all the participants for joining this session. Thank you for actively participating, making it interactive. So as we part ways, I hope today's session inspires you to explore and innovate further in the fascinating world of AI. Let us continue to learn, share, contribute to this ever evolving field, right? So thank you once again, and I wish you all the best. So have a great day ahead. So thank you guys. Thanks for joining the session. Have a good day.